Hello and welcome back to Experiment Flood, where I have the fully completed project. So I'll be going through all the blueprints and giving a brief explanation on how it meets each assignment objective. And if you want to stick around, I will play through each level and show off the game in its entirety. So let's check out all the mechanics in the final level here that combines all of them. Uh, First, you can see this glowing sphere down here near the water. This is a gravity mine that will, when you begin testing, pull objects towards it to try and set them off the path that you arranged. Then there is this drone, which will face towards and try and race you to the end point, and it reset the level if it reaches it before you do. And then this level specifically, it's tied to this cone, so you can move it around and push it further away so that you have more time to race it. And there's also these differently colored cubes around, the red ones and the blue ones. And when you actually begin the test, they will not have their gravity and just float in the air until their corresponding buttons down below are hit. So we'll arrange a small path here. So I begin the level. You'll see all the boxes drop down. The drone is beginning to fly towards it. This gravity might pull this box closer to itself. And if I hit this button here, all of the blue boxes gain their gravity back and drop back down. There is also not shown in this level the randomly spawning cubes and hazards, which just throw another dent in your plans. Huh, you can't reach it. Well, anyway. So, how do all of these seemingly random mechanics meet all the objectives? Well, firstly, to show off the principle of encapsulation, we'll open up the blueprint for the gravity mines, which just contains the imploder components seen up here. And whenever the test begins, it's told to implode itself. Uh, Encapsulation is about an object self-containing all of the information that it needs, and this component here very much does that. It has the variable values for its radius and force, as well as the different functions that it needs to get everything and uh, pull them and execute that action all within itself. You can see for the principle of inheritance that this completed drone here, each of its sections are inherited from its original drone, uh, with a new piece added on. Inheritance is about an object being based on the properties and functions of another object. This completed drone is simply executing all of the things that its parent drone did. A lot of these blueprints inherit from base classes like static mesh actor and the user widget. You can see for the principle of polymorphism in these different cubes, like the small cube here and the blue cube, uh, all of these different cubes, although they have the same physical properties and appear the same, besides color and for the gold one size, their internal blueprints cause them to act differently. Polymorphism is about objects with the same names and properties being able to act differently. You can also see this at work in the next level blueprint, where depending on the names inside of it, it acts differently. So they all function the same, simply opening a new level, but they open a different one depending on the variable in them. Same blueprint, different outcome. Then for the final principle of abstraction, take note of which variables in here I've made public versus which are hidden. For example, the drones speed float is public because I wanted to test around and make sure it wasn't too fast for the level. But all of the actor references, like in the one of these, all of the actor references, like in the disappearing platform, are hidden because I don't need to interact with those. The blueprint's the only thing doing that, so I don't need to mess with them. They can be private. Abstraction is the principle around what is and is not seen and shown in the editor versus hidden deep within the blueprints. For the variables, which are containers that store data, I have many types used within these blueprints. I use floats for the radius and pull force, vectors for locations and rotations. I use strings that convert into float names, or not float names, but names, and several object references throughout to different actors. It is important for these to not be hard-coded, as how they change can affect gameplay. Things like the starting locations of the bosses always being the same are fine, but the Boolean for whether or not the cursor is shown needs to be variable, as it can change. I use vector math in the drone to move it towards the level goal. That is all down here. Which for it, the goal is the next level actor, which it is getting from here. So it is constantly moving towards that goal using all of this vector math. This also shows frame rate independent values through delta time because it moves at a constant rate in delta seconds. So this just stays the same no matter your computer's performance. Something that doesn't use that is the game's gravity, which could very much change based on the player's frame rate. So for example, if I were to start the test and had a huge lag spike, the boxes would fall slower, but the drone's movement would remain unaffected. Levels are being loaded mainly through the next level blueprint here. That just detects whether the player walks into it and loads the next level, which is entered in as a variable. The different menus also have the ability to load the levels. The game instance is put to use here to keep track of which levels the player has completed. Since it is a singleton, meaning only one can exist, and it pertains throughout all the levels, it is good for performing these game-wide tasks that need to persist through levels. So as the player travels through the levels, they may use the level select to return to the ones that they have unlocked, and this keeps track of which ones are and are not unlocked. I make use of hit and overlap events in the level hazards, the next level actors, and the red and blue buttons. When you overlap with the water, it resets the level. When you enter the end goal, it brings you to the next level. And when you or another object hits a button, the uh, the blue boxes in this case will gain their physics back and be able to fall down. The main player input outside of the typical move and jump functions is hitting E to begin the tests, which simply destroys the disappearing cube and sets the player to the starting location, as well as triggering the custom events of a bunch of different actors to get them to know that the test has started, so they need to do their stuff. Uh, there is also the player's ability to hit Q to pause the game, which will be shown in the menu in a second. Actors are spawned in the forms of the randomly spawning hazard cubes and small cubes. And the disappearing platform can, of course, be destroyed. I make use of functions throughout the blueprints, including these functions in the imploder blueprint that tell it to do different things, as well as custom events for the test beginning and all of the different levels being completed are also custom events in the game instance here. Functions and custom events are important for object-oriented programming, and they allow the complex code to be broken up into smaller, more manageable pieces. This can also be helped by comments that label different sections of code. Unfortunately, I've not made use of those here, so much of the code still looks quite messy. All of these widgets here are used for UI. This is the main menu, pause menu, and windscreen, all based on the original user widget. And here is also all the blueprints, which I did not mention throughout. The other red cube, the red button, the drone mover, as well as the player commands, which is just the pause menu and other things. So there you have it, the completed experiment flood game and all of its inner workings as they meet the project requirements. The code is a bit messy, and I'm positive most of what I made could easily be made more efficient, but it works. Now I'm going to open up the full build of this game that I packaged and actually run through it. Yeah. I'm not the best at the game and the platforming, but I have found some pretty fun workarounds. Uh, you couldn't see here in the actual full package. The graphics are much nicer, but some things are slower, like the levels loading. And with the way I've made all these different mechanics, I can easily see how I can turn this into a full game. Most of the levels right now are just showcasing the basic elements or one mechanic, mostly acting as tutorials, but all of them could be brought together into different fun ways to create different puzzles, especially with the different multicolored cubes attached to buttons. Fun portal-like things can be made from that. level introduces the. No, where is it? Okay, that's a bug I'll have to figure out. So I was supposed to introduce the drone and heavy race against it. I guess it didn't decide to show up for work today. There it is. It's been below the level. And for this one, I just tend to build against this wall here and just avoid all of the gravity mines completely. This one right here particularly pulls a lot of them, so get the big cube up to weigh it down. See, all these ones have been pulled closer to that mine there. And then this level was made to showcase the different button mechanics. But a neat little trick is I'm not, since these boxes can also hit things, can just place them up here and they will automatically hit all the buttons for us. I found that in the actual package build, the ground seems to be a lot slippery, more so than the Unreal build. Should probably do some testing to figure out what that's about. Yeah. Then since those will just get pressed down, you can build out this path of red and blue boxes instead. They fall down, hit those. And then here's the level showcasing the random spawns. So I'm just going to hope for a lucky spawn here. This takes too long. I do also have a fun little developer button I implemented that will unlock all the levels, so I can just skip to the end. And also a button that will just teleport me to the end point there. Yeah. So I'll just do that. Oh no. There we go. So, after I totally legitly beat that level, let's see the actual way to beat this final level here. I'm going to build out the path of blue boxes away from this point, which I'm going to hit. Going to use the big gold cube to hit down those red boxes there. I'm actually going to use a fun little bit of physics with the drone and place it next to the gravity mine. So whenever it starts, it will actually get torn to shreds. And I won't have to worry about that. Well, it'll still slowly head towards it, but it'll get knocked around a bit, slowing it down for me. Placing those boxes close enough to where I'm fine with them being hit by the mine. And it's just a straight up path out to the end. This looks good enough. Do have to act somewhat quickly here. So that drone is on my tail. Yeah, and the path has worked out. It got torn up by that mine over there. You can see the cone that it follows drop down. And the gold cube here helped me out with this final red block, putting that down. And even that one over there that I didn't even need to use. And that's the win screen and the complete game. And that's done. So that's all for Experiment Flood. If you'd like to play through yourself, it should be up on my itch page. Thanks for watching.